just raise your hand. It's kind of hard to see, but if you raise your hand, you can shout it out, or maybe we can run back there with a microphone or something. But definitely welcome the engagement during the discussion. We'll have a few of us speaking, and we'll go ahead and kick it off. Again, thanks for coming. McAfee. So we like to approach the problem and the challenges that come with security a little bit differently. And what that means is we realize that security, it's largely going to be successful if it's a team effort. One of the things that we've done over the years is trying to figure out how we can provide capability to join people, processes, services, other vendors, other organizations. How can we all approach the problems of today when it comes to security as a team? Because at McAfee, I don't know if you've seen or you've heard, we say together is power. And together is power drives us. That's our vision, that's our mission. Because we realize that no one person, no one company, no one solution, no one anything is going to effectively solve the problems. Because we realize that your information, right, your data, the services that you guys provide, it's highly critical stuff. And not just here in the federal government. We've seen, obviously, with the breaches and across all the different sectors and how interconnected and communicating and how connected we are, just as a society, how devastating, maybe a completely mundane attack could end up being, not just for perhaps that organization, not just for any one of us, but for the fabric of society. So that's where we're going in this field, right? That's our vision. That's how we plan to help solve the problem, is how can we bring everybody together to form a holistic solution that's actually going to enable you guys to stay ahead of the bad guys and not let the bad guys basically, win. Because at the end of the day, that's kind of what it boils down to, is are we going to win or are they going to win? So this morning we have a few things to talk about. What I'm going to focus on first is the new approach that we have to endpoint. I imagine there's some of you in the audience, probably many of you. We can actually do a show of hands. Who here has heard of HBSS? So, like all of you guys. Who here actually works directly, like you're an HBSS admin? Okay, fewer hands. But there's at least familiarity with McAfee and HBSS, right? So we're going to talk a little bit about that, obviously, and kind of where that's going. But we're going to be presenting sort of the new platform that we have for endpoint today and going forward. So going back to the initial discussion, right? We realize this is a team sport. But how do we provide a solution that kind of satisfies the requirements and brings everybody together? And we also want to make sure that we're answering the appropriate problems and concerns of today. So one of the main customer concerns is, I just want to stop getting beat up. I want to be able to better protect my environment, and I want to be able to better protect and detect threats as they slip through. Ultimately, what that means is that the desired outcome for us is we want to give you the ability to outsmart the attackers. What we also want to do, and if you've worked with HBSS and you're familiar with EPO, you've kind of seen this, is we want to be able to collapse everything as much as possible and provide you a modular approach to do it all within one central location, right? We don't want to have to ask you guys to open 1,000 different tabs and install all these different servers. We understand that the environments can be highly complex, and we want to be able to shrink that and reduce the complexity to help you guys drive efficiency. And then lastly, the third one is visibility. So let me ask, so who here has actually had to respond to like a no-kidding event on your networks? Show of hands. How, if you don't mind, I mean, maybe you don't have to say, but how did that process go? Complex, highly complex, quick? Did it take a while? A mix of both. Lots of different technologies, right? Like, oh, show me what the IPS said. Show me what the firewall said. Show me what HBSS said. And you guys have to be the ones that put all that stuff together, right? Situational awareness. Like, I used to work at Paycom, and that was the big thing for a long time was I need situational awareness. I want situational, these are the big guys asking us as analysts. I need visibility over what's happening. And for me, regardless of how much technology I had at my fingertips, it was always the hardest question to answer because, one, you have to, well, what is it you want to know, number one, and then number two, how am I going to be able to deliver that amongst a conglomerate of technologies and dashboards and reports and everything else? So how are we able to help you get better visibility and also control? It's one thing to just see stuff, but it's another thing to be able to see the things that you're looking for and actually do something about it. So those are the three concerns that we kind of see, right? And the three desired outcomes that we're trying to deliver with our solution. So the core of that, again, as it is with endpoint, is we call ENS or ENS 10.5. So we want to be able to give you guys the ability to handle the unknowns, right? Everybody is familiar with what a signature can do or a DAT file can do. But we've also seen that although those are helpful for just weeding out, the completely obvious attacks, it's not thorough enough. There's still the heavily designed things that are going to get through, or the unknown threats, or the grayware, or the other terms that are used for threats that we don't quite know how to handle with just signature-based technologies. How are we going to be able to unpack that? How can we let that reveal what that code is actually trying to do? So we want to be able to provide you a comprehensive way to just approach the zero-day and the grayware threats. Again, better contextual defense. Again, how can you get better visibility and situational awareness out of what's happening on your networks, and how are you going to be able to respond in a highly efficient manner? So the first component that we have is, again, McAfee endpoint security. This is the new framework that we have for endpoint. So if you're familiar with HBSS, kind of follow along. So we have EPO, right? That hasn't changed. But when ENS is, we've collapsed all the different core modules, so HIPS, virus scan, the web, the firewall, and we put that into one common UI, first of all, but it's all in one platform. So it's re-architected from the ground up. It's using a technology called AM Core. So it's a lot quicker. It's able to do intelligent scanning. So if your machine's idle, it'll pick up and scan, and then when you're using it, it'll know that it's being used. So it's designed to save processing power as well. And I believe DISA has gone through and tested and accredited the product. And we can talk offline too if you're interested in becoming an early adopter of the program. But this is sort of the direction of where we've already gone with the technology, and it's going to be at least somewhat available here in the near future for testing and other purposes. Again, EPO is how we drive everything. Active response. So this gets into the contextual awareness and situational awareness piece, giving you the ability to go out and hunt, right? If you have any kind of indicators that you want to be able to search for in your network, are my machines communicating with this known bad IP address? Is there this one particular process from a named intrusion set that's running on my network? Is there a particular file hash that's just sitting out there? Is there an executable? Is it dormant? Who has it? And then what can I do about it? Can I kill the process? Can I deny the connection? Can I delete the file? That's the active response piece. Threat intelligence exchange, think of it as like the local database of threat knowledge for your environment. For example, as all your security products are working in the background, they're continuously collecting more and more intelligence on what files are on your network, what files are known good, what files are known bad, and then there's this kind of in the middle, right, the gray. Which files do we just not have a reputation for? And then how can we handle those files, especially? Is it packed weird? Is it Does it have a low prevalence? Like, is it only on 3 machines, or is it on every single machine that we have? Is it something that's been newly dropped on our network? The TIE server, or the Threat Intelligence Exchange piece, acts as that local repository. So that way you don't have a whole bunch of redundancy of meaning like, well, I need to keep the reputation for this executable on my IPS, or my host IPS, the fire, it reduces that complexity and it just stores it in one central location. Additionally, if you're subscribing to any kind of IOCs that are out there, especially for named intrusion sets, you could start plugging that into your TIE server as well. So one of the questions I got a lot was, okay, you see an NTOC report or there's a briefing, and then it's a spear phishing attack and it happened to some other command, maybe across the world, but then we would get the question, oh, well, is this on our network? It's like, that is a good question. How do you answer that? So if you have that intelligence, if you have that data, again, file hash, executable name, you can actually proactively plug that into your TIE database manually, however you're receiving your IOCs, and then be able to set that response accordingly. Like, well, I know this is bad because it was in an NTOC report, so if I ever see it in my network, just don't let it run. That kind of thing. Advanced Threat Defense Sandbox. Sits offline. It doesn't have to sit inline and scan traffic. Sandbox does both dynamic and static analysis. So it'll allow the code to detonate in a VM, which could match the image of your environment. At the same time, it'll also pull that file offline, decompile it, and examine the code statically and give you a report back. And the web protection, there is a web piece to ENS that does a browser plugin, basically. It does a few things. One of the things is, obviously, it kind of gives you a heads up of if a site is known good or known bad, or if the site that you're about to visit doesn't have a reputation. But it'll also do things like it'll work within the other products, and I think that's what the next slide is here. But this is effectively the ecosystem that we're kind of discussing today, and the components of that ecosystem. Again, all driven through EPO. Yes, sir. No, so these are a good question. So the question was, are these new capabilities that are currently being used, or is this like a futures kind of a discussion? I guess as it pertains to HBSS, it sort of depends. When it refers to HBSS from DoD enterprise-wide, you will have the ability to leverage ENS, which is the web component, the firewall component, and the threat prevention component. The threat prevention basically just takes VirusScan and HIPS and combines those together. Again, all driven through EPO. The other elements are outside of that baseline. However, so recently the US Army for Enterprise NIPR and SIPR added some of these additional elements. So the Army on Enterprise NIPR SIPR is currently in the process of implementing some of these additional controls. Right. Oh, so you guys manage Centrix K? Oh, okay. Maybe afterwards. So are you here from Yongsan, or are you here? Okay, perfect. So yeah, if you don't mind, maybe we afterwards we can chat for a few minutes. Okay. Yeah, because I was out there I think last month. Okay, but yeah, great question. Any other questions? Okay. So kind of diving down a little further into each element. So here we have sort of the core components of what makes up ENS. There is a little bit of a thing here. So let's just say that you have an endpoint, someone's browsing out to the internet. The file is actually going to be intercepted by the web control component and evaluated. So if there's a reputation, obviously it'll just block it. But if it needs further examination, let's just say that it needs to trigger an on-demand scan. It'll actually pass that file to the threat prevention piece, which again is the new HIPS VSE piece. And it'll pass the results back to the web protection piece to say, yeah, allow it through, it's good, or don't allow it through, it's known bad. that's just kind of how, that's an example of how the core components within themselves operate between each other. So a lot more contextual data is also stored. I mean, so how many of you guys have actually drilled into a HIPS event? How many think it's awesome? Exactly. Yeah, it doesn't give you a lot of data, a lot of times, right? Honestly, HIPS, it does its job very well. But one of the things that we found that was often lacking was its ability to provide you more contextual data. So the great thing with ENS is it gives you a lot more, we call it like forensic data, but it's basically just a lot more insight into what, so a lot of the more attributes of the file, basically. So the Threat Intelligence Exchange, again, we kind of briefly touched on that. It's an open connected ecosystem. The idea is that you could set a reputation for a file. Again, it could be through whatever feed that you're getting, and you can proactively set that reputation for known bad. And that's for your entire enterprise. So it doesn't even have to be on a DAT. It doesn't have to have a signature for it. You just have to know at some point, I'm receiving this IOC, this file, this hash, this IP, and I just know it's bad because of the source that I'm getting it from. And if I ever see it in my environment, I just don't want it to run. You could set that enterprise reputation to just say, just do not allow this file to execute without you having to, again, create a custom signature, all these additional things that we would normally have to do in the past to proactively defend against, commonly known or what we're kind of gathering in from other threat feeds as IOCs. And this propagates that information out to the rest of the modules, again, automatically. And it's all policy-driven, right? So it doesn't have to be incredibly stringent. You don't have to say, well, anything that's unknown, block it. It doesn't have to get to that degree, although you could. You could just say, hey, if I don't have a reputation that's known good, I just don't want it to run. And then just kind of go from there. It's obviously up to you. But it shares that information out. It publishes that information out with the rest of the components of your network to say, all right, guys, if this file's bad, if you see it, now you know. You don't have to do wait 24 hours for a DAT refresh or anything else like that. So the word that's used a lot of times here on the slide is faster. I think that's kind of the best way to just describe ENS and the new platform is that it's faster. Again, it's built from the ground up on a different structure called AM Core, and it does things like smart scanning. So if the computer's being used, it won't do the full system scan. Perhaps it'll wait till the computer's idle for a minute or two, and then it'll kick off the scan. If you reboot the system, it picks right back up where it left off. If it was in the middle of the scan. But you can see some of the metrics here. Obviously it collapsed a lot of the UIs. So if you're familiar with, you had the HIPS UI, you had the VSE UI, you had all these different UIs, right? So it's collapsing that into one UI. And I know a lot of this is kind of conceptual right now. I actually have a demo for this later, so you can actually kind of see it in use. But the big takeaway from the new ENS platform is that it's leaner and it's faster. So I know a lot of the traditional complaints, especially about virus scan, were always, man, it's kind of resource heavy, right? So that's been addressed in the new ENS platform. Are there any questions so far? No, all tracking. All right, cool. Or does everybody just want to get to the demo already? So one of the additional components we have with ENS is something which we call, there's actually two pieces, a few new pieces that kind of help really zero in on identifying that unknown threat. Again, it's easy to identify, hey, here's a signature for that file, or maybe we set an enterprise reputation for a known bad IOC, but I think, to be honest, and if we're all honest and analysts, I mean, we're really just concerned about the stuff that nobody really knows about, right? I mean, a threat actor, worth its salt, I mean, they're not going to be coding with known stuff. Oftentimes, especially for people here in the audience, it's going to be highly targeted. So that's the stuff that we really want to be able to help equip you guys with the resources to be able to handle. And one of the ways that we can do that it's, again, another multifaceted approach. So one of the approaches that we can take is, if you're familiar with like host-level sandboxing, I know that there's some folks out there that have been kind of interested in this in the past, where we want to be able to allow code to run maybe on this endpoint, but just kind of see what it does. So one of the ways we approach that problem is instead of spinning up basically another virtual container on every machine, which can oftentimes be very process intensive, we actually just let the code run. However, we don't let it fully execute everything that it's trying to do. And I can kind of explain a little bit more into detail about that later. But the idea is that there's one part where you just want to let an unknown file sort of reveal what it's trying to do. Rather than just saying, oh, I don't know what this file is, let's just block it. Because it could be a valid file, we just perhaps don't know about it. But we want to be able to do some intelligence gathering, kind of see what this file's up to. Oops. So with the dynamic application containment portion of ENS, that's pretty much what we're doing. Is we're creating like a customized container of, while preventing this file from doing the real malicious stuff that it's designed to do, we still want to see what it's up to and save patient zero. So what we can do is we can contain these processes, right? Like it says here, your EXEs, your JPEGs, your BMT files, all that stuff, and just let them run, but sort of like in a little container. So not quite a sandbox, again, not spinning up all those additional resources to put it off in a sandbox. It's just let the file run, but let's just kind of control what it's able to do. And in the meantime, let's learn more about it. So even deeper, right? So we can see here, we'll let the file run, but maybe we won't let it try to access, highly sensitive password files. We won't let it drop cookies. We won't let it inject new code anywhere. We won't let it move laterally through the environment. We'll try to deny scripts and other things from running, prevent it from writing to the registry. So those things that malware is going to commonly try to do, we'll prevent that from happening while letting the file kind of reveal what it's originally intended to do. So that's the dynamic application containment piece. There's another piece which we call Real Protect. And with Real Protect, there's two aspects. There's the pre-execution, and then there's the post-execution. I like to use an analogy of like a car. So for Real Protect, we call it Real Protect Static, which is the pre-execution piece. Think of it like if you're on the lookout for a car, right? You're going to say, well, we're looking for this car. It's this make, this model, this color. The license plate's from this state. It has this license plate number. Maybe the driver matches a certain description. Things that you can just kind of identify just, kind of outside without letting the file execute. Hey, how is it packed? What's the file name? What's the MD5? Things that are just going to be kind of statically evaluated. The other aspect of that is what's dynamic about that file. So again, if you're taking the car analogy a little further, you can just say, well, which direction is the car driving? What route is it taking? How fast is the car going? How slow is the car going? Is it driving erratically or is it driving kind of straight? So there's other dynamic things that you can also learn from a car or a piece of malware that you kind of have to use both, right? You have to employ some level of static analysis. How does this file look? What are the attributes about it? But then what's it actually doing? So Real Protect kind of combines both. And again, while DAC or the application containment portion is sort of putting up the bumpers a little bit and not letting this file execute all the things that it's trying to do. In the meantime, Real Protect's learning about this through machine learning algorithms, and it's creating a model. And then the dynamic piece actually has cloud reachback to cloud level analytics to be able to say, hey, have we seen anything matching these, this algorithm model that we've created anywhere else? So combining all those forces together, I guess, we're able to more effectively identify and provide a good reputation on whether or not a previously unknown file is good or bad. And again, we have a demo for all this, so just hang tight. Any questions about the application containment or the Real Protect models? Yes, sir. For these in particular, I have to check the compatibility, but ENS, yeah. So yeah. So I mean, similar to how in EPO you have like the McAfee agent, and there's an agent for Windows, there's an agent for same concept. So ENS has been developed for supporting other platforms additionally on top of just Windows. Any other questions? All right. All right. This slide has a lot of words, a lot of language on here. I'm going to get over here just a tad. But I mean, this is basically just walking through the workflow, right, of how it works. So it's going to gather the static properties, feeds that into our machine learning algorithms. It'll create a model, and then based off of that model, if we have anything previously known about the model that is created, then we can go ahead and convict. If we don't, then we can just kind of pipe that back to the cloud, or we can hand that off to the sandbox, like I mentioned earlier with ATD. We could put that off to our sandbox and have that further evaluated, decompiled, reviewed statically, but also executed in the sandbox VM for extra surety. All right, the dynamic piece can actually work offline, and I think that's something that important to note. The dynamic, the static piece can work offline. So if anybody is considering things like, hey, how this is going to work on CIPRNet, that kind of thing, the DAC, the application containment, and the real protect machine learning algorithms, that piece that's doing that, the static analysis, will be able to work in your non-NIPRNet environments. But again, the real protect dynamic, we're employing further level of analytics. It is cloud-based. And we in the demo, we'll kind of make a little bit more sense because it kind of walks through some of the different elements, how we use, just regular signature-based scans, and then we look at a file. We try to execute a file that maybe passes the signature-based scans, and then we actually look at a file that's employing some of these other higher level of analytics. But for an idea of how the workflow goes, Real Protect Dynamic goes as such. So an endpoint receives a file. We don't have a reputation for it, right? It's what we consider grayware. So DAC and Real Protect allow this file to run and just try to start recording what that file is actually doing and trace that behavior. It can send that to the cloud and say, hey, is there a match? I've seen this file. Here's the attributes. Here's what it's doing. Do we have an ML model that matches what this file is, or is this new? Is this a new variant? And that'll run and that'll churn for analysis to see if there's any kind of a pattern match. Again, machine learning to compare the known behavior, because there is a large library of known behavior, versus hey, is this new behavior that we're seeing? It'll send that comparison result back down. And if it's dirty, then the endpoint can ask Real Protect for a remediation. If it's clean, then, okay, well, this is just a new file. We haven't seen it before, but you know what? We checked it out. It's clean. That's how kind of how the whole workflow goes. Any questions over the workflow? How do you guys right now? I mean, are you guys having a problem? Are you needing to answer questions about unknown files, zero-day attacks, all that stuff? Anybody want to share? Uh-huh. Needle in a haystack, yeah. So you're basically trying to look for something that I guess you haven't seen before. Mm-hmm. So I guess this could help because you're looking for a behavior that you haven't seen. Right. And you basically do preventive maintenance to find the behavior that we haven't seen. Exactly. Okay. Yeah, and so me again, being a former analyst, I can totally relate, right? You have all these products, you have all these false positives that you're going through, and you're like, well, what should I really be focusing on here? So yeah, as you'll see in the demo, there is a way that we kind of rack and stack and prioritize some of these unknown files to make it a lot easier to say, here are the things that you really need to be focused on right now. And then you can start drilling down into seeing, okay, what did that file do? And then what can I do about that? Cool. Some further metrics on the new stack that we have. Again, higher detection rate and real-world efficacy, tested by third-party organizations. Yeah, just much better levels of protection. Has anybody had an issue with ransomware on like Nippernet or anything? Nobody? Oh, I see. But so nobody's had any issues, at least organizationally, right? On your users are all pretty legit, like they don't open up things, and all right. So I guess one of the things about this too is obviously we've seen maybe outside the federal space a huge issue when it comes to ransomware, especially within the past 5-6 months. These types of technologies and solutions definitely help against that because these are highly, polymorphic, right? They're always kind of changing, but what they're trying to do, underlying, it's usually the same thing. It's trying to get access to your system, encrypt your stuff, and then try to extort money. So along with just preserving the nation state aspect of it, we're also just trying to make sure that we're covering all of our bases to make sure that all the grayware is being addressed to include the ransomware. Is anybody familiar with the data exchange layer? Data exchange layer. Okay. So this was actually developed by us a few years ago, and about a year ago, it was actually published as an open standard. And basically, what the data exchange layer is, so you have this graph right here on the bottom, right? You have all these different technologies, and perhaps we want to be able to integrate them, but it requires API to API connection. Like, let's just say that if I wanted to talk to these guys here in the front row, everybody's speaking a different language. So I have to be able to speak a different language to Mario, a different language to Scott, a different language to everybody, but it's all one-to-one, and it becomes incredibly muddled. Versus, well, we all just speak the same language. That approach was taken to the technology to be able to say, hey, how can we get our products and our technologies, but partner products, third-party products, to be able to kind of speak together and speak the same language? Because again, together is power, right? We want to be able to empower, the user to leverage their environment at the fullest. And what that's going to take is eliminating the silos and getting everybody to kind of be on the same page. So with the data exchange layer, we kind of, I guess, think of it as like a fabric, right? Everybody just kind of plugs in. We all speak the same language. So instead of me having to write several different APIs to talk to several different technologies, we all just use one, plug into the grid, and it's a publish, subscribe kind of deal. Like I can publish my information out to the DXL, and whoever else is plugged into the DXL can receive what I'm publishing, but they can also publish, and I can subscribe. This is how the integration piece works. This is kind of the core of our technology. This is how everything is able to communicate and run things in an automated fashion without requiring user-level intervention. And some NSS Labs endpoint stuff. Basically, we did really well on NSS on most recent evaluations. Any questions moving forward? Any HBSS questions? Maybe you guys are holding those. Okay. So we are getting close, right? We're getting close to demo time, so almost there. Further going into active response, again, it's giving you that hunting ability. Hey, are any machines on my network communicating with this IP? Is this file hash exist on my network? Is this executable exist on my network? And if so, what can I do about it? You can also do things like set traps. So if you are anticipating, or if you want to be on the lookout for something that you know would be bad if it happened on the network, then, yeah, that one. Go up, 1, 2, 3, 4. Oh, I'm sorry. This is on my machine. Never mind. There we go. Okay, back to that. So yeah, you can set traps to say, hey, if we see this hash, I just want you to be able to delete it. Or if we see this connection to this known IP, just don't let it happen. Just deny that connection. So you can actually set up customized what we call traps as well. But basically, this is our answer to be giving you guys additional context and visibility, but also more importantly, the ability to do something about it. It's one thing to go out and scan and say, oh, well, 5 machines have the same piece of malware, but then you have to figure out, well, now what do I do with those 5 machines that have this piece of malware? And then just because I've seen these machines, oh, does anybody else have this malware? Has it spread? Is it the same code just under a different executable name? So sneaky things like that the adversary can employ, we are giving you the ability to be able to hunt for that type of thing and actually do something about it. Here is a screenshot, and you'll actually get probably a little bit of a better view during the demo. But again, all run through EPO. So if you're using EPO 5.3, 5.9, it's gonna look the same. There is, with active response, a new, not a new dashboard, but it's a new workspace, I guess is the best way to describe it. But it'll demonstrate all things like processes that are running, network connections that are made, any code injection that's happened, and so forth, to basically give you the ability to rapidly hunt and respond, especially much further and much more efficiently than you can currently with the current HPSS stack. So this is kind of the more, if you pull back the aperture a bit, then kind of an overview of the new workspace. We'll actually just kind of drive through that in the demo. It'll be a little bit easier to talk through. But what are the challenges and what are the outcomes that we're trying to drive, right? Give you a better workflow. Improve your ability to be able to handle an event, vice weeding through all these false positives and having to open up all these tabs and do all these additional steps that you would normally have to do when responding to an incident. Give you something that's lean and highly repeatable, easy to use, and really kind of helps focus on the things that you really need to have your attention focused on versus being bombarded with everything else. Again, the visibility to be able to see that and sift through that. We want to be able to give you a process, a really effective process for you to be able to conduct your investigations. Again, so much further beyond what you can do traditionally with HPSS and then other things that you can try to like MacGyver into HPSS. And take action on that because, again, visibility is one thing, taking action is another thing, right? And oftentimes that's the biggest question. Yes? So you don't need the DAC and the real protect in order for active response to work. You will need the ENS piece for active response to work. So if that makes sense. But the DAC and the real protect are sort of it's integrated into the technology. It's just an additional module. The trace. Yep. So yeah, so it's like a combination of things. So with the DAC and the real protect, it'll actually give you the trace of what the file is doing. With the active response, it gives you the ability to find out, well, who else has been affected by this? Are there any connections out there? What are the processes associated with this attack? So yes, it all works together. But again, it is modular, so it sort of just depends. It depends on which pieces you kind of have plugged in, and obviously the more you have, the better capability you have. Were you going to say? Yeah.
Yeah, we actually have different commands with it. We have some commands where they've adopted partially a lot of these technologies that Derek's been talking about, and so it's very modular in the way of just thinking of gaining the capabilities, right? So you can start from the basic what you have today, and it's very labor intensive. A lot of what Derek was describing, right? A lot of Excel spreadsheets, putting things together, pasting them together to provide leadership with visibility. But then as you start adding the capabilities, like the hunting capability, right? That's MAR. As you start getting the security analytics component, suddenly your CCRIs become simpler. Suddenly your information you're getting from EPO becomes more actionable. So now you can do your hunting better. And so we're able to work with the different organizations with a project-based or over time mentality of this is where we started, this is where we're getting, and it's allowed the commands to be able to budget for and be able to communicate as we're spending or as we're investing. These are the capabilities we're gaining. These are the efficiencies we're gaining. And it directly speaks to the technical capabilities, the technical teams, as well as the visibility that leadership gets. So it speaks to basically the entire organization, right, over time. So it's flexible. We can do it that way.
Yeah, I mean, we also want to make sure it's customizable to meet your needs, right? Maybe some organizations may not need or feel that they need a certain capability, but they want maybe a hunting piece and so forth. Almost there. Yeah, so just some more metric slides about, hey, again, just kind of talking about it's a lot easier, it's a smoother workflow, it's all driven through EPO. You work it the same you work all the other technologies through policy, so it's flexible to your needs. You don't have to put something in that's, only has a few buttons to click, and then, maybe it doesn't meet your needs, or maybe you relax things at first and then tighten the screws down a little bit as you go. So if you're familiar with HBSS and the other technologies, the concepts around it from a management perspective are largely the same, except it's just done a lot more efficiently, and it gives you a lot more capability. Yeah, the EPO one, if you're familiar with HBSS and EPO, I think it's kind of evident that being able to manage multiple things, multiple aspects from one location is usually a good thing. So if you've used HBSS and EPO, I think a lot of these are just kind of self-evident. We made it. Yeah. Okay. So yeah, after the demo, we can actually pause, and you guys can grab food because there's food in the back. So quickly, we're just going to kind of run through a few different scenarios with this demo. Number one, we're going to identify and protect against zero-day threats with signatures. So we have a bunch of customized malware that we have, and we'll just run a set of a traditional scan against those. The ones that kind of skirt by that aren't caught by the traditional signature scan, we're going to show you how you can address those with application containment and real protect. Then we're going to take a look to see, well, all right, let's just say that you protect against this, but what happens if an attacker actually obfuscates the same piece of code? Will it run yes or no? We're also going to perform an investigation of unknown files. So we're going to, on a few other workstations, we're going to execute some remote access Trojans. And we'll see how, this is more using the active response workspace, how we're able to respond to machines that are currently running remote connections via a remote access Trojan. And then pivot off of those different IOCs to see, okay, well, I see these machines running this code, but where else is that code living? Who else is communicating with this IP? And then be able to take different remediation approaches. So this is when we'll cut into the MP4.
Hello and welcome to this dynamic endpoint demo walkthrough. In this demo, we'll be able to show the efficacy of the dynamic endpoint components in action. We'll identify and protect against zero-day threats with signatures, machine learning with real protect, and contain threats with dynamic application containment. We'll also demonstrate how a malware author obfuscates malicious files, but McAfee ENS is still able to contain and detect it. Then, we'll perform an investigation of unknown files executed within the environment. We'll then use MAR to pivot off of identified IOCs to find other affected hosts. And finally, we'll perform an immediate remediation action of the processes and files that were identified as malicious. Okay, great. Let's get started. First, you'll want to launch the 4 RDP links on the desktop. We'll start with the client Win701.
A lot of this is just initial setup, so just forgive maybe the first 30 seconds or
Run
so.
the CMD agent on the desktop to show the McAfee shield in the task tray. Then, double-click on the DE demo share and download the sample files. After the files have been downloaded, I'm just going to go ahead and extract the 0-day samples onto the desktop. After the files are extracted, we're going to run an on-demand scan by selecting all of the files, right-clicking on them, and then selecting Scan for Threats. This will use our signatures to identify threats in the sample set. Signatures are still very important since they are able to make a quick binary decision as to whether a file is good or bad. I've sped up the video, but it'll just take a few seconds for the scan to run. Looks like we were able to catch 9 files out of the sample set. This still leaves a few files behind that weren't detected by our signatures, but we'll get to those in just a moment. I'm just going to open up the Endpoint Security Console so that we can take a look at the logs. For these last 2 samples, I'm actually just going to run them by double-clicking on them. We can see that within seconds, a pop-up shows that they are detected by RealProtect Client, which is our pre-execution static-based machine learning technology. We can also see a RealProtect Client detection when we look at our event log. Next, I'm just going to run that last sample. Again, we can see a pop-up that shows that we have detected it with RealProtect Client. We can see that both those files were identified and deleted. Okay, so we can detect 0-day malware with our static machine learning, but that's only half our story. Let's take a look at the other sample. I'm going to extract it onto the desktop. After it's been extracted, let's first check to see if our signatures can detect it. Yep, we can catch the sample with existing signatures, but let's try and make things more interesting. Let's use Joe Crypto to obfuscate this file and try that test again. I can launch Joe Crypto with the cat icon in the taskbar. After I've got Joe Crypto launched, I'm just going to go ahead and load my sample file. Then, I'm going to select all of the checkboxes to try to obfuscate this file as much as possible. I'm also going to select the radio buttons Convert BPs to NOPs and Mpress. I'll also need to type something into the junk character box. When that's done, I can just click on the Morph button and it'll convert the file. There'll be a few pop-up windows, but I can just close those. Now I have a converted file. I'm just going to go ahead and right-click on it and perform a scan for threats. The other file is just a backup file that was automatically created during the conversion process. After the scan is complete, we can see that even though we had just detected this file with signatures a few moments ago, it is no longer detected. Now I'm just going to double-click on this file to execute it. When I refresh my event logs, I can see new events coming in. This file is being contained and I can see multiple dynamic application containment events in my logs. After a short while, another pop-up appears that shows that the file is being detected by RealProtect Cloud, which is able to use machine learning to identify and analyze the actual behavior of the malware. And finally, we can see that the file was cleaned. Okay, that was our advanced protection on the endpoint. So now let's take a look at detecting and responding to unknown threats on the endpoint. For this demo, start by selecting Win704. Then, start Dark Comment by clicking on the round icon in the taskbar. On the system Win703, extract the file from the gift card zip and run it. You should see it establish a connection with the Dark Comment Remote Access Trojan. Next, go to System Win702. Extract the file stockplan.exe and run it. Maybe talk about how users would probably be interested in getting more stock. We can now see another connection in the Dark Comment rat. Here, we can just play around a little bit. If we right-click on the connection, we can select Quick Window and open up a remote desktop session. Now, we can see everything that the victim is doing. As an administrator, let's get some visibility into what's affecting these systems. Open up Chrome and log into EPO. After logging into EPO, go to the Active Response workspace. The Active Response workspace was built from the ground up to provide a streamlined workflow that allows you to easily identify, investigate, and remediate threats. On the left, we start with the potential threats that were identified by a behavioral analysis engine in the cloud. These will rank the potential threats by risk level and allow you to prioritize high-risk threats. In the Threat Timeline section in the middle, it might show any orchestrated attacks or threat trends. And right below that, we can see any of the systems that are affected by the threat. We can also see up to 90 days of historical threat data. When I look at the recent threats, sure enough, I can see stockplan.exe. I want to dig deeper into the process, so I'm going to take a look at the process trace. The process trace provides a flight recorder that shows the behaviors of the selected process. I can see things such as a parent or child process, IP connections, registry events, file events, or even code injections. When I click on an individual element, such as this process, it pulls up a details pane on the right. The details will show me any behaviors observed and other information, such as the file's hashes or the user associated with the process. Here I can see details of a file creation, and here's a registry modification. I can also see network connection details. It looks like the system is communicating out to this destination IP address. When I click on the IP address, it will show me all the other systems in my environment that are also communicating with that IP address. In this case, the destination IP address is the Remote Access Trojan Command and Control Server. I can see that I have another system in my environment that is also communicating it using the process hiddenrat.exe. This hidden rat is just that giftcard.exe file that we had ran earlier. I'm just going to take a look at my threat workspace, and sure enough, hidden rat is a high-risk threat. I can see the system affected by it in the affected host section, Win703. I'm just going to rearrange these windows so that we can see our connection to the command and control server at the same time. I'm going to stop and remove the threat with a host action, and we can see that the connection to the command and control server is killed almost immediately. That's pretty good for stopping a threat on an individual system, but we can also remediate a threat enterprise-wide. I'm just going to select our stockplan.exe from our potential threats. Then, with a global action, I'm going to make the file known malicious. Again, we can see that the process is killed within seconds. Now, let's go back to Win702 and extract stockplan.exe again. When we now try to run stockplan.exe, we can see that the file is identified as a threat and deleted. McAfee Active Response provides an intuitive dashboard, and we have been able to identify potential threats, perform investigations on what behaviors were performed by that threat, and easily view information from other threat intelligence sources, all within a single context. After we've identified the potential threat as malicious, we are able to easily remediate the threat and inoculate the entire environment with just a few clicks.
What do you guys think? Easier than HBSS as it is today? Yeah, it's a lot more. The workflow is better. It's streamlined, gives you a lot more capability, and it really brings to the forefront some of the things that we should really be spending our time with as analysts, right? So again, one thing to kind of point out that we had talked about earlier is ENS and how it relates to DISA. So DISA has given the ATO to be able to operate ENS. And that's kind of how you would be able to leverage these additional technologies. So if migrating up to ENS is something that you're interested in, please come talk to us afterwards. We can kind of help walk you through the process of how we could kind of get you on board with the early adopters, and then maybe even have you evaluate some of these additional capabilities, which again is me, especially coming from when I was in my former HPSS days, having this kind of technology at my fingertips would have made my job like so much easier. So yeah, do you guys have any questions about any element of the platform or the platform in general, or even HPSS? No, everybody's good. All right. Well, yeah. So that kind of wraps it up for this portion. We can go ahead and break for lunch. If you guys do have any questions, we're going to be here up at the front, happy to chat with you guys. But for now, we can go ahead and break for lunch, and then we'll pick back up here. And do you want to say something?
Yeah, so feel free to, the food's in the back. Please stick around. I'm not sure if the next section was introduced for Scott. Did you know? Okay. Yeah, so what we're going to be talking about, or what Scott's going to be talking about, is actual commands, real-world examples of this technology in use, commands sharing information, detecting 0 days. We'll be able to get into a lot of details, and you'll be able to see how this is actually working today with some other couple of commands. Scott, we'll go through that. So please grab some food, come back, sit down again, and stick around for the second half of the session. Okay, thank you guys.
All right, good afternoon, everyone. My name is Scott Jarkoff. I'm going to kind of take over the second half of the presentation today. You guys go ahead, keep eating. Don't let me interrupt your grub. I know everyone's hungry, and we want you to enjoy the food, so please continue to eat. And again, like with Derek's presentation, we want to kind of make this two-way conversation. So if you have any questions, feel free to raise your hand. Feel free to, I don't know, throw a chair at me, stop me whenever, and ask questions. I also, kind of like Derek, was previously a DoD contractor at one point. I was also in the military for a little bit. And then more recently, before joining McAfee, I used to work out at United States Forces Japan. And about 5 years ago, I joined the McAfee team in Japan. So I'm based in Japan, got a lot of hands-on with HBSS and a lot of the other technologies that we use on a day-to-day basis for network defense in DoD. So I'm going to talk about some of the pieces that Derek mentioned and kind of open the aperture a little bit, but then also at the same time discuss kind of a real-world example of how a lot of this applies today, where it's being used in DoD today, and kind of show you that what we're talking about isn't just, some theoretical stuff. There's actual implementation of this being used today, and we'll show you how that works and how it's really important to your organization, and overall how it's important to DoD to kind of combat a lot of these sophisticated threats that require the whole idea of together is power, right? Because like Derek said, McAfee recognizes as a company that we can't do it all. It requires our technology, it requires technology from our partners, it requires, assistance from a group of people. So we're doing this all together. Cracking the cybersecurity nut is not going to be done by any single vendor. And so that's why we think that this whole together is power is advantageous for the entire industry. And we'll show you how that works, again, in practice, not just in theory. So I think everyone in the audience raised their hands earlier when we talked about HBSS. I think everyone has heard of HBSS. Who in the audience has heard of ESS? Who knows what ESS is? One hand? Two hands maybe? One hand? So really, ESS is just HBSS with a brand new name. So kind of where we're at with HBSS right now is the original HBSS contract is kind of ended, where DoD is now in this process of trying to identify what technologies and what capabilities they want in the next generation version of endpoint security. And in that kind of interim phase, we're in this ESS contract phase. So bottom line, ESS is HBSS. It's just a different name. So when you hear people talk about ESS, everything that you have visualized, everything that you've touched with HBSS is identical. It's all the same. So Derek kind of mentioned all of this, the ENS platform, how it's modular, how there's, threat prevention, there's the firewall, all that good stuff. So, basically what you're currently using with HBSS, where you have VSE, which is the antivirus component, anti-malware component, what you have with HIPS is kind of the host-based intrusion prevention, a kind of, desktop firewall, the kind of simplistic version of application whitelisting. All that good stuff is basically somewhat added into ENS. And then the other parts that Derek mentioned of the web control, of the threat prevention through like DAC and RealProtect, et cetera. That's all kind of done in ENS in this modular fashion, right? Instead of how it's currently being handled in HBSS. So that makes for less resources on the desktop required in order to make this run, and it's faster, it's more adaptive. We're allowed to, or we're capable of adding additional features to ENS based on current threats, emerging threats, new technologies, and excuse me, and whatnot. So this is kind of the DoD Enterprise's vision for how all of this works, right, in theory. And this isn't really anything different than what Derek really talked about. So we have on this screen, all the way on the left, you have the network security boundary, which is, you know, generally where your firewalls and your IPSs are positioned. And then you have ATD for doing the sandboxing detection that, say, for example, the IPS can pass off a file over to ATD for execution in a sandbox. We have threat intelligence that Derek talked about for sharing intelligence across multiple technologies. And that uses, as you can see, that blue line down the middle, uses OpenDXL for communication between our own technologies and also through our, or with our partner technologies. So all the partner companies that we work with are able to leverage OpenDXL, write code using that platform and those libraries, and then, as Derek mentioned, publish or subscribe to OpenDXL. So we can publish threat data to DXL, or we can subscribe and ingest data, whether it's we as in McAfee or as it's we as in our partners. We can use that data across multiple technologies. And then we also can then send that data over to, like, for example, HBSS, ACAS, and all the other tools that you're used to using in DoD, right? So as just an example, I think we have some cute animation here on the slide. So for example, an endpoint opens up a file. That file gets sent over to Threat Intelligence Exchange. So it gets sent to Ty because it's unsure whether it's you know, safe to open or not. Ty will then send that over to ATD. ATD will then open it in a sandbox. It'll, you know, take a look at the behaviors. It'll do a static analysis on the file. I think a lot of this Derek mentioned previously. Not much different. And then let's say in this case that ATD has determined that this file is malicious. It's taking some, you know, suspicious actions, and we feel that we should not allow this file to execute, so we don't. ATD recognizes this, and it shares that information. Come on. It shares that information with the boundary security, and then with Ty, and then with all the endpoints and all the other devices on the network. So ATD has, I'll get you in just a sec, ATD has convicted a file as malicious, and then using DXL, it shares that with all McAfee technologies, and then we'll share that with all of our partner technologies. So yeah, go ahead, shoot your question in the back there. So as third parties are integrating with DXL, how do we ensure the integrity? That's a very good question. Yeah, so I think for OpenDXL, we're using kind of a certificate-based system to ensure that yeah, not like an attacker, for example, can get on the network, use our OpenDXL code, and then just start publishing, you know, for example, false positive data, or publishing data that would say that malware is in fact not malicious, right? We have measures in place to ensure that the integrity of the data is actually valid, right? Because we don't want just everyone to be able to start publishing, right? Because otherwise, then we can run into a situation where then nothing is malware, right? Because all the malware authors are leveraging DXL to show that their malware is in fact safe. So yeah, there are safeguards built in. I don't know. Do you have anything to add to that? Did I miss something? Yeah, I think really what it boils down to is just certificate-based. So, you know, just how Windows does certificate-based authentication between the different server types, we do the same thing, right? And you want to add to that? Sure.
Yeah, so, I mean, that's a great question, right? Think of it more like in the IT world, where you have a standard like syslogging, for example. It's just the fact that there's information that lives in one place and in multiple places, and you're just trying to get it to another system or another environment. But the way syslog is written is it's a standard, right? I don't have to talk to a company or an owner of anything. I just make my output fit a certain set of rules. So DXL is very similar in that it's a way to write to a standard that even allows folks that are doing custom coding. So like we work with some of the CPT teams out of Maryland. They come out to Pacific, and they looked at the standard. They did some of the questions that Jay was asking about, like how do we leverage this? How do we write some of our own tools so that instead of having to manage a lot of custom sharing elements of their custom tools, they stopped using that. They just started publishing into the Excel to get the information out of EPO, to get the information out of HPSS, out of ACAS, right? So before they were having engineers code this and maintain custom code, they were able to decommission that and then just leverage the open standard of the Excel, right? Like at some point, probably folks were doing database sharing with custom coding, and then later SQL scripting came up, and you just do SQL scripts, right, to move data around. So I think it's more along those lines.
Any other questions on how this all works? I mean, that I think is probably the, I don't generally talk at the kind of tactical level for most of my presentations. I talk more kind of strategic, but oftentimes I get that kind of question about, hey, how do we ensure that the bad guys aren't leveraging, you know, this open standard to kind of poison the open DXL network? And, you know, really ultimately it just boils down to we've put safeguards in using SSL and certificate-based encryption. Anyone else? No? So then also Ty will then take all that data that was shared earlier, and then it will also share it over with ACAS, and it'll end up populating the scorecard and kind of making your lives easier as network defense analysts who have to put together, you know, that information for your leadership and whatnot. So this is not just helping defend the network, but it's also helping with the situational awareness piece as well. We're trying to make lives easier on both sides of that coin because, you know, it's, as Derek mentioned, situational awareness is hugely important, and we recognize that if an analyst has to go in and then start populating Excel spreadsheets or start typing things into EPO, then it's probably just not going to get done. I know when I worked at USFJ, I had to put together this 25-slide PowerPoint presentation every week on the current status of the network, and it was just too much work. I mean, I did it because it had to be done, and I had to get that information shared with senior leadership. But how accurate was it? You know, was it really as accurate as it could have been? And I think when you have stuff like this where we're just publishing data and pre-populating in kind of an automatic fashion, you're going to find that your data is much more accurate and provides a much better picture to your leadership. So I think this is more or less the same thing, just a little bit different view. So basically we have files that are downloaded from the internet off of, you know, there's workstations that live inside the network and hit some website. I don't know, maybe it's CNET, maybe it's, you know, download, I think download.com is CNET, but it could be anywhere, right? Maybe you're in Gmail downloading files, who knows? The sensors are able to detect these file downloads, right? And then we pass that data all the way over there to the right side of the screen, which is essentially the, you know, where all the analysis is taking place. Like that's where ATD lives, for example. And then that data is also shared with the manager. So there's a management console like EPO. I mean, we're talking about EPO. You're able to see the status of what's going on with these technologies in the manager, but at the machine-to-machine layer, Ty will then share this data, again, with other technologies through the use of OpenDXL. And then we can also do some advanced analytics to try and determine some more sophistication, try and determine if there's additional sophistication that we might have missed. But then I think really what it boils down to, and what's more important, is that when the data is shared through OpenDXL, not only do we have to share it only with our local network, not only with those endpoints and those technologies on our local network, but with also downstream customers. So let's say using, I don't know, let's use Paycom as an example, because I was at USFJ. Our higher headquarters is Paycom. So if Paycom's employing this kind of architecture, for example, as soon as they find a threat and they publish that threat, USFJ being a subunified and being subordinate to Paycom could leverage all this data. And it can be all done machine to machine, automatic. It could happen at 3 o'clock in the morning without anyone knowing what's going on. And then the analysts come in the next morning and they find that something kicked off. There's no need for IR necessarily because it was all handled automatically. All of this is just done magically. And again, not just with McAfee technology, but with our partners as well. And we're doing things like this in not just in DoD. These are being done in other areas of the world as well, like at the Japanese Ministry of Defense. We do something very similar. All right, what is this? Oh, so again, and just to kind of wrap up this slide, we talked about some kind of network hunting, or Derek really went into detail with the network hunting, right, with the MAR piece, and then the EDR and the automated intelligence sharing. Those are the automated intelligence or threat sharing is really the big piece, right? We really want to be able to share that knowledge because, again, not to kind of harp on this whole together is power, but it really is. It really works. And so here, I think we're going to kind of transition over to a real-world example out of JSOC. So we're talking about kind of on the left side, the traditional, what we're kind of used to with just this static HBSS where there's no threat sharing in the kind of old version of HBSS, right? And then moving towards a more adaptive cyber threat defense model where we're using OpenDXL and we're using that machine-to-machine communication to share threat information and threat intelligence automatically. And as I mentioned, it's all automated, right? So we're talking about things happening without an analyst having to push a button. You don't have to be sitting there in front of the console monitoring it. You can be doing other cyber defense tasks that are probably more important than sitting in front of EPO pushing buttons. You can expect that the machine-to-machine communication via OpenDXL is going to happen. It's going to take care of sharing that threat intelligence. It's going to automatically remediate the whatever it finds on the network and kind of take it from there. So in this, let's see, what do we got next? So here's kind of the architecture of this particular use case out of JSOC and CENTCOM. So I don't know, Kobe, do you want to come up and kind of?
Yeah, my name's Alex Chapin. We got Kobe here also. We're both going to talk a little bit about this. I just wanted to kind of set this up. I started with a meeting with Mr. Halverson. At that point, he was the Department of Defense CIO. I had a meeting, somebody's trying to get in here. We had a meeting at the Pentagon, and we kind of went through this whole, we call it ACTD, Advanced Threat Defense. And I went through it with him, but the most important part of our conversation was around how do we share IOCs across the enterprise and DoD? And once we start doing this, how can we change the game on how we do, network defense? And he really, really liked the presentation to the point where he goes, let's do a pilot. I want to see this done on the military network, and I want to see how it works. So from there, we went down to CENTCOM, we went down to JSOC, we got the kind of permission for them to do it, and the information that we're getting ready to talk about is kind of the result of that pilot. But what was most important also was, when I was talking to him about it, is the fact that, today, all the C&D that we're doing is in silos. So you've got a guy or a gal that's working on the firewalls, right? And they come in every day and do their thing. You've got somebody working on the HBSS system. You've got another maybe group of people coming in and they're working on their network IPSs, right? And you have all these different, I'll call them cylinders of excellence, right? Within the cyber world where they're doing their thing, right? And they're not, talking to each other beyond, trying to take spreadsheets and say, hey, we've got IOCs that have come down from above, and then, you got to go to the firewall guy and kind of plug them in there. If their IP addresses that are bad, if it's hashes, you got to go to this team and try to get them to do this. And what we need to figure out is a better system of sharing that information. So we want to get to the point where we have that flat file that's coming from either NSA or whatever it is for tippers, and we want to be able to put that in this system and let this system transport it across all of the enterprise, right? So then at that point, and we keep talking about this DXL piece, right? So, and everything we've been talking about is all the widgets that we have that connect up to DXL. But what will be most important in the end is if we get the Palo Alto folks to connect into it. So then, at the JRSS stack, they're finding something, and we're finding out what those IOCs are, and we're sharing it down to the endpoint, on the HPSS systems. And once we have the whole community in this, and everybody's sharing this at the same time, what you're going to see is a couple of things. We're going to find tippers, and we're going to field it really quickly, like within seconds instead of days or weeks. And then the second part is we're going to be doing a lot of self-discovery, because we keep talking about how we're catching stuff at the endpoint or potentially carving stuff off of the network. And once we do that, we're sharing those IOCs instantly across the enterprise. So, and this is kind of teed up to where Kobe's going to talk about specifically when we put this system together for JSOC and CENTCOM, what the realization was from that pilot, right?
Yep. So basically what we did is we stood this up, like Alex said, we set it up JSOC at Fort Bragg and CENTCOM at MacDill. It leverages all of the components that we talked about earlier. It's the Advanced Threat Defense, ATD, which is the sandboxing, which does a static and dynamic analysis. It leverages TIE, which is your on-premise zero-day threat database. It does that for the lookup. So if it sees something on the network, it doesn't have a signature, but it looks suspicious, it'll ping TIE and say, have you seen this before? If TIE says, nope, I've never seen it before, it hands it off to ATD, the sandbox. The sandbox runs through the analysis, says it's either good or bad. If it's bad, gives that back to the TIE database, and it says, this is bad, block this file at all of the endpoints, all of the network components, anywhere where I can communicate to, make sure that this file is blocked, and that's what it does. So I'm going to run through, we've kind of gone through what the architecture is on here a little bit on the earlier slides, but I'm going to talk to, no, it's okay. Leave it there. Yeah, so I'm going to talk a little bit about two of the events that they had. They ran this pilot in production for about 6 months. It was a total of about 5,000 to 6,000 production users. This isn't in a lab environment. They didn't put, host or malware against it that they knew about. This was in their production environment. So the first 0 day that they caught, so they had it in there for 6 months. Within about the first 6 weeks, they caught their first 0 day. And what it was is a phishing email. Somebody got a phishing email. It was from a bank. It was either U.S. Bank or something like that. And it's kind of funny hearing the CND chief talk about it. He's like, so somebody clicked on it. They don't even have an account at that bank, but they clicked on it anyway to see what their balance was. And immediately it started downloading malware. And what it was is it was a brute force attack. So it was trying to gain administrative privileges on the network. It got down to the McAfee agent that's sitting on the endpoint. That's part of HPSS. It said, this looks suspicious. The activity that it's doing is not right, but I don't have a signature for it. Antivirus isn't going to pick this thing up. So it did the whole send it to TIE for the analysis. TIE gives it to ATD. ATD says it's bad, and they blocked it. Now, at the point that they did that, we had CENTCOM and JSOC on two separate networks, or they weren't sharing IOCs yet. There was no, database where they could send the IOCs to and have it drop down to the other command. So that just protected JSOC. Then we set up a MISP malware sharing database at CENTCOM that JSOC had access to. And that way, if JSOC got hit or CENTCOM got hit, it would automatically send that file, whatever it is, to the MISP database, and it would share that automatically with the other command. So the second 0 day that they caught, which was about, it was about 2 months, 3 months later. It was a Friday afternoon. Somebody at JSOC went onto their AOL account and downloaded a file and was looking at it and everything, and then they left for the day, right? So they go home. The file detonated at about 2 o'clock in the morning on Saturday morning. So, and I forgot, I've got the details I can give you guys if you want to come see me later, exactly what that file was trying to do. But it basically detonated, and it went through the whole thing. It was, I believe on that one, it was the network. It was one of the IPSs that said, this looks suspicious, not malicious, I have no signature for it. Carved off that file, sent it over to TIE for analysis, or TIE for the database, and then ATD. The beautiful part about this is it identified it, it blocked the file at JSOC, and then over the weekend, it sent this file to the MISP database at CENTCOM. So, and then CENTCOM comes in, actually they both come in first thing in the morning. JSOC gets the report when they first sit down at their desk, and they're like, we got hit with a 0 day over the weekend. And they checked their system, so that file was blocked everywhere. They called CENTCOM, the CND chief at CENTCOM, and they're like, hey, we just got hit. Have you guys seen this? And they're like, they checked their systems. Everything was protected before CENTCOM ever got hit. So it completely automated over the weekend to share that IOC and protect both commands. And then the other funny part about it, and it's not funny, but he kind of makes a joke about it. He's like, about 6 hours later, we get a tipper saying, hey, this is a bad file that's out there in the wild, you might want to block against it. So these guys, they were protected 6 hours before they got the NSA tipper on it. So that's it. That's all I have.
Great, thank you, Kobe. Thank you, Alex. So that's a nice real-world example of what we can do with OpenDXL, with sharing of threat intelligence, and it's great because there was no human intervention at all. This was all machine to machine, right? And ultimately, just imagine if if PACOM had been tied into this, and if the PACOM subordinate commands like USFJ, USFK were tied into this, they could be sharing and consuming all of this same threat data, and we can get the entire community sharing threat intelligence without any human intervention. And maybe the same thing could have happened here, right? Just like with CENTCOM, had PACOM been plugged into that, there's a good possibility that had they received the similar type of file, had somebody tried to open that same kind of file, it would have already been blocked, right? So this is really just a good news story on how this OpenDXL platform, how sharing threat intelligence is really important in DoD today. So it's not all about just kind of automating certain processes, but it's all about sharing that threat intelligence to help protect all the different networks at kind of the network speed, for lack of a better way of saying it. I think the next couple slides actually go through some of the details that Kobe was talking about. So here's the first one that Kobe mentioned. So this is just the ATD threat analysis report that just kind of highlights some of the details from this particular threat. I'm not sure that there's anything super exciting to read here, other than you see that the dynamic analysis, it's basically a severity of very high, and then we have the behavioral classification. We're talking about very high possibility of it spreading, and using the network for spreading. So just some analysis that if you have never seen ATD reports, this was kind of some of the details that you can get out of it. And then the next one is this is the AOL account file that was downloaded, and this, I guess, as what Kobe was mentioning, this is the logical breakdown of the malware. I think we're kind of running short on time, and I want to give you guys some opportunities to ask questions, but this really just kind of outlines how this all went down. But the bottom line is, again, it was prevented machine-to-machine via OpenDXL. And MISP, as Kobe mentioned, is open source. So it's not like it's a product that you gotta spend money on. It's not a McAfee product, right? This is just something that lives out on the internet. Anyone can download, anyone can leverage it. All you need are the OpenDXL scripts to tie it into TIE, right? So that TIE can share information with MISP. But better yet, it would be the better option would really be for DoD to kind of tie this all together at a DoD level, right? Everyone maybe tie into the CENTCOM database, and then that way all of DoD is sharing all this information automatedly.
Yeah, it's actually, it's purchased. So they just, they're pretty much done with the pilot. I mean, both of them have purchased solutions within the last, couple months. But this is, and that's, it's actually a good point. You talk about, JSOC and CENTCOM, sorry. But this solution is actually, we're going to be deploying this in the Army, too. It's already been purchased. And this is for, if you look at the scale on this is for Army's 1.4 million users. I mean, they're going to be sharing IOC information between the two primary data centers that the Army has. So we've got the Army that's deployed this out. We have several commands that have done this, have the solution. They're just not doing the sharing yet. So there is no MISP database. I mean, they have the ATD and the TIE. We've got a lot of customers that have that. They're just, the JSOC CENTCOM was just to show how we can share that threat intelligence and do it, we can even do that on a larger scale. So, yep.
Have you had a situation where someone hasn't been sharing and then a threat wasn't caught, but it was still on their network, and then you put a sharing in, and then with the upload of those threats detected, they were then able to detect the threat that was still existing on the network at the time after they started sharing?
We haven't really, I mean, we didn't run into that when we were doing the testing and all that. Haven't seen that. I mean, it's going to identify new stuff that's coming in. There's tools that we have that will do the hunting and look for that stuff. But what this is identifying is anything 0-day that's being hit by that command. Okay.
So I can't name the organization, but
Yeah.
what basically happened is the big challenge we have in security these days is that when we scan for files or vulnerabilities, the file actually needs to, the service has to be running, the file has to be executed, right? So what we've run into is that as we enable these technologies, we find dormant files, right? And then with that dormant file, we do what I think Derek touched on, which then we ask the question, where was this file before? Like 6 months ago. So suddenly the SIM becomes more relevant. But it's only because we've been able to focus that view into something that now I can go hunt for, right? And then we find out that, yeah, 6 months ago there was somebody that came in the network, they put a file on, and then they deleted it, right? Well, now I can go and say, what machines did that machine speak to? So again, the big stack of data starts becoming relevant, right? And then we find that there were other IP addresses. Then we start going back, what were these IP addresses? What were their malicious rating? We find that 2 of the 3 were. And we just keep digging. So what we've been able to do now is get engineers and cyber engineers to do this type of work, the hunting, the going after more information. So now we can go, sir, ma'am, not only did we find that this machine was bad, but we uncovered all these other activities behind it that we had no idea unless we have zeroed into this one. And then now leadership can basically say, I want you to keep observing, I want you to stop it here, I want you to brief me again in an hour, right? So suddenly it goes back into being a commander, being commanding the mission and not having to be experts in cyber, because it's just another aspect of warfighting, right? So that we run into.
Yeah, sure, go ahead.
So somebody might say, for example, what Scott was talking about between PACOM and the other units. USFJ might say, on this environment, this network, I'm going to take this action. The rating is just passed. I can actually say, I'm going to look at that rating, but I'm also going to do my own analysis here, and then do some breaking of, you know, this one's good, this one's good, this one's bad, right? How does it work, right?
I'm trying to conceptualize in my mind, like, if you have two different tie servers, one command opts to say give PS exec a malicious rating because they don't want it to run
Right.
a reputation, but then another command chooses not to do anything and they're sharing that data.
Yeah.
Yeah, I'm not sure how that works.
Yeah, so you can,
I think
yeah.
So when we did this pilot, it was interesting because we got both teams in the room, and what turned out to happen is they didn't trust each other for, if you're the other command to say it's malicious, they're like, I didn't trust that as much as, but when they looked at when they both used ATD, which is our sandbox, they both, organizations trusted emphatically that that was going to convict on something that was really known malicious, and they trusted that reputation and were able to share that amongst themselves. But they weren't willing to take the information that, like, if somebody populated something in the TIE database and said, I think this is, like, human person said this is malicious, they didn't want to accept that part because they were afraid that somebody would be like, look, I'll make it up. I don't want Facebook running on my network, and I think that's malicious. But the other command could be like, I want to run Facebook, right? So that's like kind of on a case-by-case basis. But the other thing we're kind of working on is like, okay, so how do you start categorizing IOCs, right? 10 is really bad, we accept those, but when we get down to like 5, then we start becoming, not so sure we want to do that. So maybe we only want to block like 8, 9, and 10, because we know for sure that that's going to be bad. And then if you want to make a reputation on your own, and we have to examine what that is and whether we want to accept that into our organization as a blocked or a known malicious, right? So it was kind of interesting, but they for sure were fine with machine to machine with ATD. They were like, hands down, we'll deal with this and it's good, right?
So with DXL, there's different events based on what machine or what technology is doing what with the file. So in this case, I think you have two separate events. You have ATD convicting a file, so that's some machine-based automation right there, versus an event that fires when an administrator goes into TIE and then actively blocks PS exec. So those are two different events. So in this case, as Alex was mentioning, if you choose to share the machine-to-machine communication, then you'll get that automated defense that Kobe went into with the JSOC CENTCOM stuff. But if you don't opt to subscribe to or to share the events that are, kind of human driven, like what Alex was saying, then I think you're able to do that. So that's how you can make that differentiation where one command can keep PS exec blocked and say another command can then can allow its use, right? Yeah, and then it all goes down to just how the OpenDXL code is written to share that data, basically maybe with the MISP server or whatnot. So I think it's there's some granularity that you can get down to make it work the way that'll be valuable for your command or beneficial for your command, so that you're not ultimately preventing things from executing that you would actually prefer to execute, or vice versa. Right, exactly. Nobody wants a self-denial service, right? I think we're more or less done. So this is just kind of an incident summary. I think this is what Kobe mentioned that he could kind of talk to you about. So we can probably talk offline about this because I think we're at the just about at the end of our time. But if you want more information about the actual malware itself that was executed at at JSOC, then we're more than happy to share that information with you. And so these are just a list of some of the partners that we're working with for OpenDXL. So Forescout, Red Seal, and then, I mean, probably everyone in the audience should be aware of ACAS, I suspect. Who knows about ACAS? Right? So, you know, it integrates with us with no problem. So it's, you know, just another way to automate information sharing.
And more and more people are jumping on board to go on this fabric, right? So Infoblox, for example, we have them in the room. They're part of the group now too. And the cool thing is that they're not coding to McAfee. They're simply writing to a standard, meaning now technically they can speak to Forescout, right? Without them actually ever talking. And then the same thing, Cisco just released too, that they're sharing information from their mail gateways, right? Mail gateways, and firewalls are coming and different elements. So even when we get somebody as large or part of, environment like Cisco is, to play nice on an open standard, I thought was a huge win, right? For the fact that I think we're on the right path, right? But then what we're also getting is what we're talking about, like not one single company can do it all. There's a lot of really good technologies out there that become even more valuable when they're sharing and they're letting us digest some of that information and us, sharing with them as well. So it's moving forward, and every day, every week, we get more.
Yeah, this is just a much broader view of the architecture that we've discussed, and I think the next slide. So, I mean, everyone's probably aware of the DoD Cyber Scorecard, and so with all the information that we've been talking about, the bottom line is all this threat information ends up making it onto the Cyber Scorecard to make your lives easier, to understand exactly what threats are on the network, what vulnerabilities exist, and then you can share that obviously with senior leadership for the reports that you need to get them so they better understand and have the better picture, better situational awareness of their own networks, right? Yeah, so no more, so like in my case, that 25-page PowerPoint, no more. This is all automated, right? And I can actually get them data that is, in fact, accurate, whereas with the PowerPoint, there was a lot of guesswork involved, right? I mean, yeah, you can probably export some data from the different technologies on the network, but really, ultimately, how accurate is that? When we're just talking, at the machine-to-machine level, I think the accuracy of the data is a lot more trustworthy, right? So that's the active cyber threat defense that Derek presented. That kind of gives you an overview of how it all works. And then, a really strong use case. And I think ultimately moving forward, we want to kind of get, more commands like Paycom and whatnot tied into these types of technologies because it's going to be beneficial to help the commands prevent threats from occurring on their networks, right? And again, I think we're at the end of our time, but if you have any questions for us, feel free to, stop by the booth. We'll be more than happy to share detailed information about the threats that we discussed or answer any questions that you may have. Thank you guys for your time. Appreciate it. Thanks for coming out.